Welcome to my Friday presentation, week 3. So basically, what I did is this is the first chart I created. It's a pie chart because it's kind of interesting to look at the pie chart. And the second one is this. I actually sorted out and regroup the bunch of groups. And let's talk it first. So you see, these are so even though there are so many cities, but each city, the area represents how often the frequency that this city, the crime is above the average. So which means, if there is a year this city's crime is above the average, is bigger than average, then will appear one time on a pie graph. Well, so let's say compared to Milwaukee, this Miami date or Miami is definitely less. It appears less than the Milwaukee, so which could mean that Milwaukee have more crime generally, I'm assuming. So let's and this is just group up all of the cities to several big um, categories: east, west, south, and middle. And of course other. Honolulu doesn't belong to any of those groups, so it's definitely a outlier. And I'll explain my code a little bit. So basically, reading the data, and so this is the filter if the total crime is bigger than the average. So I will only look at uh, those things. And second, this is basically add a count. So I create a new column called a city count. So for say this is telling you that in this year the crime is the in city in Atlanta, the crime is the total crime is bigger than the average. So this to one thing to notice that this average is the entire average of the data set, so it's not the year, which I actually could try to do something of that. I think we're good right now. So and then I group them up together. So the total amount of the city count will group up together, and then this is the chart. But this chart definitely has a problem, which is there are so many cities that it's kind of actually complicated to recognize that. So after that, I kind of put them in the different groups. So these groups, some of them I do have information that they clearly belong to any of the for example east west, but some are not very clear. And you can notice that there's no north city, which is well, you can say Minneapolis is a north city, but it's more a middle west. So there are only east, west, south, middle, and of course Honolulu. And then I put them in different different groups. And here you can see their name already changed. So yeah, so in all of these things, so the east and the south cities have definitely more crime records than south, and then west and the middle cities. You can see from the pie chart, and yeah, it's very obvious. And you can kind of tell that east and the south cities are a little bit same, but they're definitely more than the east and the west and the middle. So what does this tell us? Does this tell us that cities in east and in south are more uh, dangerous, have more crimes? Because I actually think about this. Where this entire data set is about the clearance. So it doesn't mean that it has more crime. It actually means has more crime that being solved. So I'm assuming but I will right now I will interpret them as basically more crime. So the problem is, even though in these charts, east cities, south cities definitely have more years or record than other parts, but you can look at here. You can look at here. In total, in total groups, east cities, there are more east cities on this group, and there are more south cities on this in this entire data set than west and the middle. So it's actually predictable and expectable that east and the south city have more record, because they definitely in a group they have more element, they have more cities in there. So we can actually say that this is not 100 accurate, and because of the number in a group is different, which makes the graph different. So yeah, and this is what I want to talk about for this Friday, and thank you very much.